A couple of days ago, an interesting study by the University of Chicago has been released about the impact of AI, or specifically AI agents, on programmers, or specifically the output of programmers. Does Gen AI and do AI agents make us more efficient? Do we produce more output with it? That's kind of the angle this study came from and analyzed. Now, here is a blog post on the Cursor website, because in that study, they used Cursor, or they looked at companies that were using Cursor, to be precise. And I can already say the study results are such that, of course, Cursor felt inclined to publish that summary of the study, because the study finds that companies that embrace AI agents for coding do get more done, have more output, more mergers, more pull request mergers, I mean, not company mergers, and more lines of code being written in the end. And I want to take a closer look at that study. So this is the latest version. Now let's take a closer look at this study and the findings in there. The question is, how do agentic AI systems affect productivity? That's the core thing they are taking a look at. And with that, they mean productivity of companies and programmers employed in those companies. Now, I did actually go through the entire study. I did not just summarize it with AI. And I want to share some of the interesting things I found in there, or I found interesting about that study. Now, in this abstract here, they already mentioned that more experienced workers are more likely to accept agent-generated code, where we have 6% higher accept rates amongst more experienced developers. So they're saying that the more experienced developers are, the more likely they are to use AI agents and accept the code that was produced by those agents. And that might sound weird when you read that the first time, but I think it actually kind of can make sense. If you get more experienced over time as a developer, you of course know better typically what you want from your code, which code you want. So as you're building new features, you have a pretty good understanding of how you would want to build them. And without AI, you would write that code or tell your junior developers how to build a certain feature. At least in code reviews, you would, of course, try to get that code into the direction you want it to. And if you're using AI agents, you have a better understanding of what to ask for, because I think that's the important thing. If you are less experienced, so if we would draw a chart and we have work experience on the x-axis, then if you're less experienced, you of course might know that you want a certain feature, but you don't know exactly how to get there or what the best way of getting there is. So you might be using AI, but you might not be super confident in its output. If you are more experienced, on the other hand, then of course you typically have a better understanding of what you want. You can ask more precisely for what you want, and that is the key difference. You can give the AI more precise instructions, and that can then lead to a higher acceptance rate than for junior developers, for example. That's kind of my explanation, also the explanation they have in this paper in the end. And that kind of makes sense, because it is similar for me. As I said, I'm using AI a lot, and I use it for very precise edits. I have very specific instructions. I provide a lot of context when I send my prompts to AI. I'm not saying make the header blue. Instead, I tell it exactly in that file, please adjust it such that blah, 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 whatever my changes. So I have very small, precise edits, and therefore I have a high code acceptance rate, because there's less room for error because of these precise instructions. Now, in this study, in the abstract, they also mentioned that the weekly code merges indicate that software output when using AI agents increased by 39% after the agent became the platform's default code generation mode. So companies were getting more done if you just look at the number of code merges of pull request merges. Now, I'll say it right away. We can definitely argue if that is a good measure. Of course, when using AI, you can use it to generate way more code, including some bad code potentially, and that could lead to more code being merged into the code base. I will say that in this study, they actually also try to implement some measures for the code quality. So they look at how many merges were reverted or how many bug fixes were published after code merges to kind of see if those merges maybe were of bad quality, and they found no meaningful differences there, kind of implying that it's really more code being merged without the code being worse. But still, we can argue about this measure because just as the number of lines of code is not really a good measure for code quality or productiveness, as you get more experienced, you might know that sweet feeling of actually making a code change that removes more code than it adds. There's nothing better than making or than merging a pull request that has a net negative amount of lines of code, so that reduces the amount of lines of code in a code base. That's a really nice feeling. Obviously, it's not always the goal because having a code base of 0 lines of code is not going to do the job, but I think you get what I mean. So just measuring if there's more output does not necessarily mean that it's better output. Nonetheless, of course, if we're talking about code merges, it's not saying anything about the lines of code, it's just merges, and these could be merges that make the code base better by cleaning it up and so on. So they find evidence that with AI agents, more merges are happening. Now let's dive a bit deeper into this study and not just read the abstract. And what's interesting is, or what I want to start with, is this experience gap in agent accept rates. I already talked about it, that it makes sense to me that more experienced developers know better what they want, and therefore they might be happy to accept the code generated by agents because it is more specific. But in the study, they also mentioned that experienced workers are more likely to develop plans with agents. And that's definitely also something I want to pick up on. It's not just the case that as you have more experience, you can ask for more precise edits or code changes. But of course, you also, because of your experience, can make better plans. So you're not just asking for a certain change, but you also plan it better. And that's kind of related to what I mentioned before when I said that I provide very specific context to the AI when asking for changes. That's part of a planning process where I make a plan of how do I get to a certain result? What do I need to consider? Do I maybe have a reference implementation I can give the AI to look at so that I can say, hey, build me a file upload feature. Here's an example where we already do that, but I need the same feature, but with these changes. And things like that, really not just asking for a feature, but making a plan of how to get to that feature and what to consider when implementing that feature. That's, of course, also something that comes with experience. And you might not be able to make a lot of plans if you're early in your journey, but the more experienced you get, the more you can, of course, plan. And that's also something they found here. And of course, with AI, planning helps. There is a reason why Cursor and Claude Code, why all these tools have a plan mode nowadays. So that when I have a prompt, which I send to Cursor, for example, I can switch to a plan mode to first have it create a plan before it actually executes it. By the way, this plan mode in Cursor and Claude Code and so on, of course, is also kind of a please fix my prompt mode, which can make up for a lack of information in your prompt by analyzing it, analyzing the code base, and then asking follow-up questions. So here, for example, if I send a prompt to the AI asking to draw me some shapes with the Canvas API in plan mode, it will very likely come back to me with some questions asking me for more details. And that is the thing that can improve the code quality because, again, it's all about providing the right context and being more specific with your instructions. Now, in that paper, they also got a nice chart related to code acceptance and to agent usage style by different characteristics. And that is quite interesting because in there, First, if we scroll to seniority, we see that the more senior developers are, the more likely they are to accept those code changes or code generation suggestions created by Cursor, by the AI agent. And more junior colleagues actually have lower acceptance rates here. And the scale here in this paper basically means if 1.0 is the average acceptance rate, then senior developers are above that and junior developers are below that. We also see what's quite interesting, that management, executive, and non-technical staff had much higher acceptance rates, which of course also makes sense again, because they don't know anything about the code quality, so they just accept it if they test it and it gives them the result they want. Junior developers, on the other hand, know something about writing code, so they seem to be more prudent. They're not just happy with it working the way they want, they want the code also to be good. And senior developers are kind of in that sweet spot where they know what they want, they can see that it works, they can also judge the code quality, and they asked for, or they were more likely to ask for specific features in the first place, hence having higher acceptance rates, which makes total sense if you look at it like this, at least in my opinion. We can also see that the usage also is quite interesting. Senior developers, they actually were less likely or used AI agents less. They had the lowest usage amongst all the groups that were looked at in that research. So they had a high acceptance rate, but low use, which of course also again makes sense. Not using it for everything, but using it for precise edits or precise requests. And of course, if you're not trying to do everything with AI, you can have a higher acceptance rate in return. Junior developers used it quite a bit, but accepted not a lot. And executives used it a lot and also accepted a lot, which I guess makes sense. Also because we all know that, especially amongst executives and managers, there is this strong feeling like, oh, we gotta use AI. AI can do everything. And they just come to you, tell you, yeah, just use AI and you can get it done in a day, what previously took you a week. So that can be very difficult because they are just so convinced by AI, because they don't necessarily understand a lot about it. They don't understand necessarily what your job especially is, or they don't necessarily understand the complexity of writing code necessarily. They just see, I can ask AI, it seems to work, that's perfect. So that can definitely be challenging because these are the people you have to deal with. But yeah, that's also something we can clearly see in this study. Also interesting, by role, we can see that designers used AI agents a lot and accepted a lot, which again is that same theme. You just want to get something done. If it looks right, yay, you're happy. And on the other hand, software engineers had a very small bandwidth, which is interesting. So there was not a lot of variation within the group of software engineers. And they use it, well, they're on the lower end of usage in that chart. But then they are also in the lower end of acceptance, because again, they are the only group in that entire chart that understands the output and that don't just look at does it work, but also at does it scale, is it secure, is it maintainable, did it add a lot of bloat, and so on. So it's more than just looking at does it work. And of course, software engineers are basically the only group in there that understands this. Now, in that paper, the author also discusses a semantic shift in work patterns. And what he means there is that people who use agents produce software using a natural language interface. This usage style may influence the experience of programming. Now, I did publish a video only a week ago where I discussed the topic of English being the programming language of the future. And long story short, you should watch that video, but no, it's not. If we wouldn't have programming languages the way we have them today, I'm sure we would invent them in exactly the same way, because human language, English, German, whatever, is very noisy. It's not very precise. It's good for human-to-human interaction because we can put a lot of context in there and so on. But if we write a computer program, we don't want a lot of variation. We don't want 20 different ways of expressing the same thing. We want to be deterministic. We want to be able to be precise. We want to have a language that allows us to express something in a way that doesn't allow for interpretation or variation in interpretation, I should say. So yes, when we use AI, we of course interact with those agents in using our natural language, in English, German, whatever it is. And that is actually an extra translation step that then is done by the AI between what we tell the AI and the code that is being generated. Now, that's not necessarily a bad thing, just to be very clear, because of course the output still is code the way we want it. And as software developers, we can judge and tweak that code. And then using natural language is just a means to writing that code quicker, so to say. We could write it ourselves, but why am I using AI when writing software? Well, I'm using it because I can be quicker if I know I want to build a certain feature in a certain way, and I can describe it in detail. I can provide references and useful context like documentation, but then instead of just writing the code myself, it can be quicker if the AI generates it for me and I then just review it. And I want to be very clear here. I have been definitely in a situation, like we probably all have, that I asked the AI to implement a certain feature where I then wondered, well, maybe I would have been quicker if I would have just done it myself, because maybe I had a couple of unnecessary iterations, because the AI got it wrong, maybe I wasn't happy with the result of the AI, maybe writing the instructions simply took me longer than it would have taken me to write the code, especially with auto-completion and so on. So it is a double-edged sword. But of course, we got that shift that when we use AI, we use natural language to describe our intent. But, and that's really important to me, we still need to be able to understand the code, because if we don't understand the code, we are basically back to these charts. We are basically in the area of, let's say, designers, where we use AI a lot and we accept all it gives us because we don't understand what it gives us. And of course, that then can have different problems, because code, as we all know, by AI might work, but might not be maintainable, might contain bugs, might have security issues. So we don't want to be there. We want to use human language, natural language, to express our intent, but we don't want it to replace programming and programming languages. I don't want that, at least. Now, as I mentioned initially, the study also took a look at the output that was generated with help of AI. So the code merges, or the increase in code merges, for example. And what they found is that as the agent mode became the defaulted cursor, code merges kind of, or the number of code merges kind of trended up. Now, the chart they have here is not the actual absolute number of code merges. Instead, it's a difference chart comparing the number of code merges to the baseline, so that we can see the difference in code merges to the baseline. And we can basically see that it was fairly stable up to AI agents becoming the default. Maybe a slight upward trend since AI agents were available, but then a steeper kind of upward trend once they were the default, arguing that companies simply got more done compared to their average output once the AI agents were the default. And the revert rate, on the other hand, stayed stable. So the argument is they got more done, but the code was not worse. Now, one important thought here, as I mentioned before, quantity alone is not a good measurement. And the measure here, the revert rate, and the number of bug fixes that were published after code merges, these are short-term metrics, and they reckon that in the study. They clearly mentioned it, that these are short-term metrics. Of course, long-term, the question will be if that increased output leads to problems with maintainability, technical debt, because maybe something is merged without introducing a critical bug, but still maybe with code that doesn't fit into the general architecture of the project, or that doesn't follow all code style rules of a certain project that might violate certain code style rules and was accepted nonetheless. Now, these are just guesses. Nothing of that is mentioned in the study. It is just possible that the increased output will lead to problems long term. Also because of one other effect that's important to me. As your use in AI increases, so as you use more and more AI, your skill decreases. So if I have my skill on the y-axis and the use of AI on the x-axis, you could say the more you use AI, the more your skill decreases. Now, this is not always correct, of course. It depends on how you use the AI. But if you start relying on it more and more, and that's the important thing, if you don't critically judge the output generated, if you just take a brief look and accept it and you don't fully understand the code that was generated, if you're just looking at it, checking for obvious errors, then your skill will decrease and your understanding of the code base will also decrease. And that can, of course, be a long-term problem. As we use AI more and more, if we use it by blindly accepting its code or without critically challenging the code, we have the danger of our skill decreasing, of us losing the skill or getting worse at writing good code. Let's put it like this. It's not something you will lose forever, of course, but it takes you some time to get back to your old level. Use it or lose it. And understanding of the code base, of course, also gets worse if you use AI a lot. And that's something I've definitely also been at. When I built an MVP or a prototype with AI and I didn't care too much about the code quality, I had basically zero understanding of the code that was generated. And it took me a lot of time to get into it and then took significant changes to convert it to an actual product I was happy with. And that, of course, is one potential long-term problem you could have with overly high reliance on AI, even if short-term all measures look good. So that's something to consider. And therefore, I found this study quite interesting. It's interesting to see that companies that were part of this study had higher output because of AI. The acceptance rate and percentage of use statistics by role and seniority also were quite interesting in my opinion. And as I mentioned at the beginning, I am definitely a fan of using AI for programming. It can make you more productive. I'm convinced by that. It does make me more productive, but only if you use it right. And I've said that before. It is definitely also something we still all have to learn and something that will change over time. Using it too much can definitely be a problem. Ignoring it entirely also doesn't feel right to me because, again, if you know what you want, you can get it to generate some code quicker than you would have been writing it yourself. It can, and that's not even part of the study, it can, of course, also help with learning or with understanding code. If you're getting into a code base you don't know yet, it can help with onboarding. These are all positive effects I see. The big danger just is that we humans are lazy, and if we then trust it blindly, if we fall into that trap of using AI for everything without critically thinking about the output and without challenging the output, that is where I see a lot of potential problems on the horizon, and that is something we collectively have to learn and master, and that will, of course, be difficult. Anyways, interesting study, hopefully also interesting to you, and please let me know what you think of that study. Maybe some points I didn't discuss, maybe something I forgot or you see differently. Let me know, and I see you in future videos and episodes.